Hello and welcome to a session where we're going to talk a little bit about, whoopsie, about some grade 10 math. We'll start with some review things, perhaps to some, getting us into laying the foundation to get us into the uh, algebra things and the slightly more challenging things. Let's just start with the first one. I mean, why not? So, even though, let's check if this is big enough. We're going to use IXL for generating some examples for us to discuss. They're a very good website, so I encourage you to go look at it if you are interested in any way. Totally up to you. So let's talk about factors first, because if we don't understand numbers and factors, then when we go to algebra and talk about factors, but with variables and expressions, even though the same concepts are there, people view it as different when it's really not. So when we have the number 6, let's just start with a simple factor tree. We can write that as 2 times 3. Neither one of these can be split up in factors other than 1 any further. They're both prime numbers, and so we call 2 a factor of 6 because 2 times 3 gives me 6. 2 times something else. 3 is also a factor because 3 times something else will give me 6. So we'll go here and say 3 is a factor of 6. You can also think of it as 3 being a factor of 6 because 6 divided by 3 is a number with no remainder. Well, there is a remainder. The remainder is 0. So we can think of it that way as well. So we have which numbers are factors of 15? So we are trying to write 15 as some number times some other number. I can write 15 as 5 times something. So 5 is a factor. I can write 15 as 3 times something. I can write 15 as 15 times 1. And I can write 15 as 1 times 15. So they're all factors. You can also view it as division and say, well, 15 over 5, 15 divided by 5, is a number here with no remainder, or a 0 remainder rather. Let's clean that up a little bit. So we have 9 and 1. We're looking at, besides 9 and 1, what's another factor of 9? Now I know these are very basic, but these exact things happen when we're looking at algebra, and they are really that simple, even though it looks much more intimidating. What's another factor of 9? Well, 9 is 3 times 3, so 3 times something will be 9, and therefore 3 is another factor of 9. Which number is a factor of 18? Well, I need to look at it in two ways, division or multiplication. They're related to each other very closely. Can I write 18 as 7 times something? No. Can I write 18 as 4 times another integer? So in this situation, we're only talking about integers. So yes, if I include some decimal numbers, I can write 18 as 4 times something, but that is not an integer. Not an integer. So we're talking about divisibility in the integer sense only. 18 can, however, be written as 9 times something with, and that's something being another integer too. and 18 cannot be written as 8 times another integer. So in this sense, we're only talking about integers, and 9 is a factor. Besides 16 and 1, what is a factor? Another factor of 16. Well, I can split 16. Let's actually do a factor tree here just to practice and make this a little bit more than what this question perhaps is. I can write 16 as 4 times 4, really two numbers, but whichever one comes to mind. I can also do a 2 and an 8, whichever one you prefer. Then if I can split the number up further into integers, in this case 2 and 2, and this 4 is also a 2 and a 2. Now these are the ends in my factor tree because they are prime numbers. In the integer sense, they can't be split up into other non-trivial numbers. I'm not using a 1. And so that's the end here. So I can write this as 2 times 2 times 2 times 2, or 2 to the power of 4. So I can now take any groupings of these prime factors, and they will always be divisible by, or into. 16 will always be divisible by that. For example, I can take, let's say, 3 2's. So 2 cubed is a factor of 16 because I can write 16 as 2 cubed. Looking at this, there's another 2. So 2 cubed, my divisor, my factor, times something else. That's an integer. So another factor of 16 in this case could be, for example, 8. But we could have also taken 2 squared. Any selection of 2 as well. Any selection of these prime factors will give me a factor. We got it. Which numbers are factors of 8? So again, this lays the groundwork for the algebra we're going to move to in grade 10 very quickly. And people skip over the number sense, divisibility, factors, multiples. And then when algebra comes, they're completely lost, not realizing that it's just building on these exact concepts. Which numbers are factors of 8? So let's take a look here. I know 8 is super small. I want to write my 8. Let's do a little factor tree, maybe a 2 and a 4. 2 is a prime number, so that ends that part of the tree. And 4 is a 2 and a 2 again, all ending. So I'm going to write it as 2 times 2 times 2 this time, just to mix it up. So now any selection of this, let's change the color. Any selection of this, just a 2 is a factor. 2 2's. So 4 is a factor. I'm not sure if you can see that very clearly. I'll go black. Or all 3, that's also a factor. So any selection of these prime numbers, the building blocks of the number 8. And of course, I can take none of them, and therefore 1 is also the trivial factor. So 4 is the yellow one, 2 is the pink one, 1 is not written because it's the nothing, the trivial one, and 8 is the black one. They're all factors of 8, just selections of the pieces that make up the number, the expression in question. Let's do this one a little bit faster. We're not doing too many, we're just laying the groundwork, getting a sense of divisibility, factors, very important moving into algebra. Last one, perhaps? Yeah, let's make this the last one. Which numbers are factors of 4? Now think that 4, let's go black this time, is made up out of 2 2's. So I can select none of them, and then 1 is my factor. I can select only one of them, they're identical. So 2 is a factor. If I selected both of them, 4 is also a factor, but that's not in my list here. And we are done. Great job. So hopefully this laid groundwork. You can practice this one on your own. Laid the part of the groundwork, moving deeper into grade 10. I'll end with a little uh, plug for encouraging you to ask some questions and let me know how you feel about this video, if you have any questions or thoughts. That's it for today. Thank you and have a good one.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.